Okay. Section 5. We are going to take the final step and find where the parabolas cross the x-axis. But before we do that, let's do a little bit of review. I popped this graph on here, and I pulled this off of my graphing calculator, and that's a grid function, and I'll show you how to do that later by using a grid on your calculator. But first of all, let's kind of zoom in here, and please identify with a red dot the vertex. Then, with a green dot, go to the point -1, -4. How far over, how far up? Do we agree 1, 1? Okay, I'm going to go to purple. I'm going to go left 2 and up 4. How far over, how far up? 2, 4, right? So what do you see as a pattern here? Do you agree the pattern is 1, 1, 2, 4, 3, 9? Yes. So what's the value of A? 1. Okay, so let's put a little note there that says A equals 1. All right, I'm also going to put the axis of symmetry down, just because I like to draw it, to see it vertically. Yes, sir?
If A equals like 3, is that over 1 up 3?
Yeah, and then over 2 up 12. You would multiply by 3.
Got it.
Whatever the A value is, you multiply your up value by that A value. Really simple. All right, my vertex. Who can give me my vertex?
-2,
-5. -2, -5. My axis of symmetry. Aaron, you can't answer because he did it before, but remember, this is an equation. What's the equation for the axis of symmetry? Allison?
X equals -2.
All right, x equals -2. Now, the y-intercept, we don't use a ton, but if you zoom in here, what's the y-intercept? Right there? Would you agree with that red dot? Okay, there's the y-intercept. The y-intercept, remember, is a point. So what is that point? 0, -1. All right, then there's a question. Is the vertex a max or a min? Do we all agree it's a min? So let's circle min. Now, the space down below here is for us to write the equation. I think we should be able to do this fairly effectively. Y equals 1, parentheses, x minus h. So what does that become? Plus 2 squared plus k. So we're adding a -5, so I guess I can put -5. Now, do you think that's how the book is going to be?
No.
What is the book not going to have? The 1. So, just realize that the book is not going to have the 1. Is it wrong if you have the 1? No, it's just what? Awkward. Okay? All right, moving down. Are we all good there? It says complete the square. To complete the square, remember our goal is to get this vertex form, just up here. And so it looks like I first need to get the 14 over by the y and the 6x over by the x squared. And so I move those over. My goal is to get the x squared plus the linear term on plus the constant, and the constant needs to be a perfect square trinomial to help this all work together. So let's put in our plus blanks. Y minus 14 plus blank, 6x squared minus 6x plus blank. Raise your hand if you know what the blanks are. Curious how many of us know them. About 2/3 of us. Morgan, go ahead.
+1.
I completely agree it's +9. Can you explain why?
Half of 6 is 3, 3 squared is 9.
All right, half of 6 is 3, 3 squared is 9. And Carson, this is that section that we missed, we're still going to catch up on. All right, so now Carson, the next thing I'm going to do is I'm going to take this right side and write it as x minus 3 squared. And the way I know that is the minus sign follows from right there, from the -6, and the 3 comes from half of 6 or the square root of 9. Make sense?
Yeah.
Okay, and on the other side it's easy. That's what, y minus 5, guys?
Yeah.
So my final equation, y equals x minus 3 squared plus 5. I hope you realize the vertex is 3, 5. This parabola is going up. It has a minimum. The axis of symmetry is x equals 3. All of those things. What's the pattern on this graph? Is it 1, 1, 2, 4? Okay.
Wait, why is it -3 again? Is it just because?
Positive 3. Why is this negative 3?
Why is axis of symmetry -3?
I'm sorry, the axis of symmetry is x equals 3. Maybe I didn't speak clearly. X equals 3. The opposite of that number.
Okay.
All right, let's slide over here to our second example. The big difference here is there's a 2 in front of the x squared, but we're still going to bring the 60 over first. Do you agree? Now, watch what I'm going to do. I'm going to do a second thing on this first line. What do you think I want to do with that 2? Factor it out. Good, Max. So x squared minus 10x. Now, in all of my classes, everyone said, why don't you just take out a 2x? I don't want to take out a 2x. I just want to take out the a. Just that scalar, that multiplier. That's all I want to take out. Owen.
Before you move the 60 over, can't you just divide that by 2 as well?
You know, I want to bring that 60 over and just get that constant out of the way.
I know, but then it's a smaller number.
Right, but then it's going to be inside your parentheses and you're going to be dealing with stuff on the inside. And so it's really just get it out of the way. We'll deal with it later. Because our main priority, folks, is to really, our whole purpose is to figure out what this blank is with the red line. That is the whole purpose right here. Everything else is incidental. That's the purpose. And from that blank, everything else follows. Now let's think together. How do I get that blank again? Simon, be clear.
I think you would multiply 2 and 10.
Do it the same way we did the first one. How did we get the 9?
You just split the x in half.
Yeah, so let's do the same thing. What's half of 10? 5.
And then 25.
And 25. So that 25 is key. No, because 5 squared is 25. I know. But anytime you square something, it's positive. Now, are we really adding 25? No. We're really adding 50. So, because 25 times 2.
So you do it as normal over there.
Yeah, you just do everything as normal.
Then you multiply by 2.
By that scalar, yeah. All right, so let's see what this pans out to. That's y minus 10. That's 2x minus 5. And for those of you who are wondering where that 5 comes from again, it is half of 10, or the square root of 25. Why is it a minus? Because right above, we have a minus 10 right there. That's why it's minus.
I have a question.
Yes, sir.
Wouldn't the blank be 100?
What's half of 10?
But wait, I'm confused. Because negative 20x, that's where you take it from, right?
No,
The top.
we take it from right here.
Yeah.
That's where we take it from.
Yeah.
Good question. Good question.
Yeah.
We always take it from when it's just x squared.
Yeah.
Owen.
Why, or like, how does the 25 automatically just disappear because you're not?
It didn't disappear. It's 5 squared.
Okay.
Remember, if you x minus 5 squared means x minus 5 times x minus 5. Do you want me to work it out just to show you so you can visualize it?
No, I got it.
And then you FOIL that, and that's where you get the 5x and the 5x that makes the 10x.
Yeah.
And the 5 times the 5 makes the 25. So it's still there.
Okay.
So let's write our final answer. Y equals 2, x minus 5 squared plus 10. Do we all agree that the vertex is 5, 10?
Yeah.
Does this one have a pattern 1, 1, 2, 4?
No.
No, it does not.
Would be
1, 2,
1, 2,
2, 8.
2, 8. Yes. Yeah. Because you multiplied it by that stretching scalar. So I wanted to give you these 2 illustrations here just to help us review a little bit. To really, you guys have kept doing better and better each day and get this solid. just to make sure that we're comfortable there. I think you're going to do fine as we continue on. So, all right, well, let's slide down. And we're going to talk about solving equations by factoring. Now, over here to the right, in each of my classes, everybody's asked, why are we doing this? So here I have a random graph. And I'm going to take a random graph and I'm going to draw a random parabola on said graph. And I'm going to put the two key points that we're talking about today on this graph. That point and that point. And these 2 points are called solutions. Another name for them is x-intercepts or roots. And it is where the graph crosses the x-axis. And so this has a special spot, x equals some number, and that has a special spot, x equals a different number. And I don't know what the numbers are. I don't really care what the numbers are right now. But that's our goal today, is to finish the factoring process. We're going to set it equal to 0 and find where the graph crosses the x-axis. So that's the picture behind what we're doing. And I wanted to give you that overall picture before we jumped into here. That being said, I put a couple steps up here. Step 1, set the equation equal to 0. Then factor out a GCF, and notice what it says. If possible. Then factor what's left completely. Set each factor equal to 0, and notice I said each. You may have 1 factor, 2 factors, 3 factors, 4 factors. Then we solve each new tiny little equation. All right, so let's try our first one here. And this is a great practice of factoring as we get ready for our assessment today. Without looking up at the board, can you tell me my signs? Plus, minus. What do I know for absolute certain? Because it's x squared, I know it's what? X and x. So x and x. Possibles. Factors of 8 are 1 and 8, 2 and 4. Which do you want to go with? 2 and 4? Do you want to do 4, 2 or 2, 4? Now, why do you choose that lane?
Because I know if you look at it, it's going to become a 2x and a
Yeah, so a 2x and a negative 4x. So does that quickly say, hey, boom, that's it? So we're good. This is where we stopped the other day. But now we need to finish the problem to find where this parabola crosses. And so what we do is we take each part, and I'm going to split it up. And I'm going to take each part, and I'm going to say, hey, x plus 2 equals 0 is one part, and x minus 4 equals 0 is another part. Does this look semi-familiar from Algebra 1?
Yeah.
It should. It should. We solve these tiny little equations. What does the left one solve for? X equals what?
-2.
And the right one?
+4.
Positive 4. And now we want to write our solution. Negative 2, comma 4. That is called solution set notation. That means those points are where this parabola crosses the x-axis. That's what it means. So in this case, had this little graph up here to the right been that, these 2 points that we were talking about would have been -2 and +4. All right, let's look at example 2. Intentionally, this is not equal to 0, which is causing us to start the problem by setting it equal to 0. So bring over the 16, if you would please. Second, look for a GCF. Is there one?
No.
Okay. That's not a bad thing, but we always want to start. Here we go. Christian or Loredana, can you tell me the signs?
Positive and negative.
Positive and negative. I agree. Christian, you good with that?
Yes.
Okay. Don't forget your equal 0. What do we know for absolute solid, absolute certain? 3x and x. Okay. Do you care where they go? No, because if it's opposite at the end, we'll flip them, right? So 3x and x. All right, 16. What are my possibilities?
1 and 22 or 11 and 2.
So I got 1 and 16, 2 and 8, 4 and 4. What do you want to go with?
4 and 4.
Okay, I heard 4 and 4. That gets you negative 12 and positive 4. That's negative 8. That didn't work. So 4 and 4 are gone. Do you want to try 4 and 4 and reverse them? No. Okay. 2 and 8. That gets me negative 24, positive 2. Are we really close?
Yeah, but just switch the sign.
Okay, so I'm going to change that positive 2 to a negative. I'm going to change this negative to a positive. Are you okay now? Do we have our factors? Now we take it, remember, we kind of branch it off with two little y's. So we're going to branch this off. So that gives me 3x minus 2 equals 0, x plus 8 equals 0. Can anyone solve the left one for me?
X equals 6.
So 3x equals 2, and then x equals, you said? 2/3. And over here, x equals negative 8. So let's write this with solution set notation. Negative 8, comma, 2/3.
Do they have to be in any order if the order better or not?
They don't have to be, but it's proper if it's written that way.
That way the
When someone introduces your parents, they typically introduce your father first. Why? It's custom. It's a standard way. When I talk about my children, I say Kent, Stephen, David, Jessica. Does that mean Jessica's the least important? By no means. It just is the way that is standard. You talk about your children from oldest to youngest. That's just what we do. So standardized here in math is we typically say the lowest number on the number line first, all the way up to the highest number on the number line. Just so it's a standard way to do it. It's not wrong, it's just awkward. Okay? Who are the children in my family? David, Stephen, Jessica, and Kent. That just doesn't roll, right? I have to think about it. So we want to just be standard. That's all. Don't freak out about the positive, negatives, and all that kind of stuff order. All right. I'm going to ask you the same question. Look for a GCF. Do you see one?
yes.
What is it?
X 4.
That was good. I heard X and I heard 4. Teamwork. So, 4x. Who can tell me what's left? X squared minus 1. Can I go further? I heard no and I heard yes. I guess if you're a no, you could be satisfied and stop. If you say yes, then you have to give me what's more. Abby.
If you would go 4x, parentheses, x plus 1, and x minus 1.
Excellent, Abby. Nice. Nice. Why can she do that? Because it's the difference of two squares. X squared is a perfect square. 1's a perfect square, and they're separated by a minus. Will it always go further? No, but it might. How many factors do I have? I have 3. How many times does this thing cross the x-axis? 3 times. It's not a parabola. So each one of those equals 0. So we solve each one. First one, x equals 0. Second one, x equals negative 1. Third one, x equals 1. Solution set, negative 1, 0, and 1. Did I go too fast there? Are you always going to have a GCF? No. But pay attention to what Abby did. She didn't stop. She looked to keep going. Sometimes you will, sometimes you won't. Let's slide over. 8x cubed plus 22x equals 6x. What do you think we should do first?
Minus 6x from both sides.
Yeah, I like that, Simon. Let's bring that 6x over. So 8x cubed plus 22x squared minus 6x equals 0. All right. Once again, look for a GCF. Do we have one?
2x.
You guys are a good team. I should let you take the quiz together. That way you'd do well. That would be nice. I always offer that as an option for anyone who wants to do a team quiz. That's perfectly fine. You can turn in one paper, and I'll grade it, and I'll completely score it the way you turn it in, and I'll take the points and cut them in half and give half to each person. So if you want to do a team quiz, just let me know. We'll put this together. You can even talk out in the hallway and collaborate. We'll let you do that. Okay. 4x squared plus 11x minus 3. Now, I've had some freshmen actually try to take me up on that, and then I stop them. I say, you probably don't want to do this. What are my signs, guys?
Plus minus.
Plus minus. I feel bored. Now it's any plus minus here. Hey, doesn't it have to be 3 and 1?
And 2x.
Well, it doesn't have to be 2x. It could be 4x and 1x or 2x and 2x. Which would you like to try? 2x and 2x? All right, 2x and 2x. That gets me negative 2x, positive 6x. Not what I'm looking for. So I'm going to erase the 2's. What do I want to go with? 4 and 1? Negative 4x, positive 3x. All right, so I think 1 and 4. Negative 1, positive 12. Does that work? We got it. But even so, on the third try, we got it. That's all it took. 3 tries. This is not hard. Abby, can you make that from there? Go ahead and try. So 2x equals 0. X plus 3 equals 0. 4x minus 1 equals 0.
Oh, wow.
Nice shot. X equals 0. X equals negative 3. Can you guys help me with this one? X equals what? The last one?
1/4.
Positive 1/4. So negative 3, 0, 1/4. And just to give you a little idea of what this looks like, a x cubed function looks like a zigzag. If we were to graph this, just very quickly, it would look something like this. You don't need to graph that right now, but that's about what it would look like. And notice, where does it go through? It goes through at negative 3, it goes through at 0, and it goes through at 1/4. So that's kind of what it looks like. You're going to learn how to graph those later in the year. It's really simple, no big deal. Don't worry about it for right now. But I just want to show you what it looks like, just to give you a big picture. All right, let's look down here at example 5. You guys have done a great job so far. Let's jump to some new people. Rebecca, Annalise, Julia, talk to me about my first step. Subtract 8, she says. All right. Look for a GCF. No GCF? Sad. Okay. No GCF. So let's do our parentheses. Plus and minus. 3x and x. You want to go 8 and 1, or do you want to go 4 and 2? 4 and 2. That's negative 6, positive 4. Are we close? We're really close, right?
You just need to swap the signs.
Swap the signs, okay. So let's change those signs. Did we have plus minus before? So now we need minus plus, is that right? Okay. Okay, so let's set them each equal to 0. 3x minus 4 equals 0. X plus 2 equals 0. 3x equals 4. X equals 1 1/3 or 4/3. X equals negative 2. This is the one time where you might not have a 4/3 as an answer. If you were graphing it, kind of hard to graph 4/3, so you go 1 1/3 if you had to graph it, but we're not in this case. Questions there? Example 6 has a typo, so I need you to help me here. If you'll zoom in to the 2x And if you would please put a squared function right there, we now have a problem that I originally designed versus a problem that does not work. Okay, it's already equal to 0. So let's see if you guys with your teamwork can pull up the GCF.
X squared.
I was hoping to get like x and x, you know, and combine them together, but x squared is correct. Who can tell me what's left? Allison, go.
X squared plus x minus 2.
Do you agree with her, guys?
Yes.
I do. So the x squared comes down. Plus and minus, x and x, 2 and 1. Let's check it. That's negative 1x, positive 2x. Did that work?
No.
Yeah.
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 Negative 1x plus 2x.
Yeah.
Yeah, that works. Okay, so let's set each of our factors equal to 0. X squared equals 0. X plus 2 equals 0. X minus 1 equals 0. So take the what of this one? Square root. Negative 2. Positive 1. So let's write our answer. Negative 2. Positive 1. 0. Questions? 3 answers here. Okay. All right, so our homework is going to be this worksheet. It's just 16 problems. There's a front and back, so you have plenty of space to do, 8 on one side, 8 on the other side. So we should be in good shape there. All right.